Hello everyone, hello ALIAS Nation, welcome to this week's video tutorial. Just a quick mention that the full-length video of this tutorial will be soon available in here. In the meantime, all the other ALIAS video tutorials are under the link in here. The link to my website is in the description. So without any further ado, let's jump right in. In this 20 minutes video tutorial, I wanted to show you how sometimes you can come across the situation where working to theoretical intersections simply doesn't work. Like in this case, in the case of building the nose of McLaren 765 LT, if I try to just follow the common rule of building the fillet of the theoretical intersection, theoretical edge, the result isn't really good. So I wanted to show you how we can go forward, go a step ahead, and use my kind of idea of modeling backwards. So basically we will begin by realizing first of all that our current fillet is not good enough. It doesn't represent the shape, and then we are going to delete the history and start walking backwards basically. So from the fillet, we're going to take that fillet, we're going to place it where we want it to be, and from that fillet we are going to build adjacent surfaces. So you can see that at the moment this round is nothing like we want it to be, and also we don't have continuity. So there is a lot of work and waiting. I'm just performing different kind of testing and different kind of analysis. You can see also that in the middle the comb is peaking, so we have to address that problem as well. There is a lot of work to do. Basically 90% of the time I'm using the comb curvature plot tool to find out the quality of my surface. Sometimes the alias wouldn't give you the continuity green icon, and you will be struggling a lot with the continuity failure, but at the moment this is not our concern. We are not worrying about this. What we're worrying about is we're going to create and we're going to use any legit ideas just to make our round do what it's supposed to do. So basically be close to the digital data. Obviously the digital data is not 100% accurate as well, so we don't need to be 100% accurate. This is not a digital scan. This is just a set of NURBS created with the subdivision mode in ALIAS. As you can see, I'm sliding because as you probably know, this sliding method doesn't destroy the CVs as such and doesn't make our round look completely different. In fact, the round is close, so going up, down, forth and back wouldn't be a good idea. Sliding is the best option. In this video, minor tweaking and minor sliding will take majority of the modeling time, so be prepared to get yourself bored to death with this. But again, the result will be would be something that you can be proud of. Remember to look at your geometry from every angle you think it's needed. So basically, front and side, top and even bottom. At the same time, you can see that there is no continuity. We can slightly tweak the CVs if you see any weirdness, if you see any misalignment, like this CVs, the one I'm pulling now, it's pointing upwards. At the same time, you can There you go. I think we just had G2 continuity, and we can probably there you go, here it is. We can actually be happy about this. Okay, so yeah, we have a good continuity. The other problem is that we have to now take some of the CVs and pull out, as you can see, just to make the comb a little bit better. Yeah, that's fine. I think it's good. Now we can focus on the top portion of the surfacing. I think the surface is diving too much inside the car itself. That outer edge is too much inside. But at the moment I'm trying to align our round to the other patch and see what happens. Many times you figure out what your workflow is going to be as you go along, basically. So there's no like a ready plan for everything. You should be trying different things and at the same time think whether what you're doing is right or maybe there should be another approach. Many times you'll find yourself having many different ideas that you normally wouldn't be able to think of if you didn't try and fail. So this is not failing, this is just a progress, but very slow. Sliding CVs just to make them slightly better. At the same time, keep an eye on the comb plot and keep fighting with that yellow or red icon, which shows you the failure. Just making some minor adjustments to make sure that this patch is kind of aligning nicely with our digital data, the digital subdivision data. To be honest with you, I sometimes don't understand why in situations like that I can't get the continuity. If you look at the curvature plot, it seems to be fine. Nevertheless, I'm still struggling to get that continuity right. So basically, this happens very often. You should be ready for situations like that, and you should know what to do. You must be very patient with your work. You must be kind of know what to do, what your next step is going to be, and also maybe you should be even thinking of a couple of steps ahead. Okay, this will come with experience. Okay, sometimes I have a silly idea that at the back of my head I know that maybe wouldn't work, but I still try. I still try to impose those ideas, because failure of this idea might be the beginning of the next idea, which might help you to build something nice. So never reject anything. Try to be interested, try to be enthusiastic about your job. After all, you never know, maybe your idea will work, maybe your idea will be fine. Maybe by trying something that you have never tried, or you think it's weird or strange or would never work, by doing such things you learn, and maybe you can apply your ideas, your different types of ideas in other parts of the car. Alright, so looking at the model from the top, again, the comb curvature plot should become your best friend. You know, you should just get used to looking at it and also squeezing the view if necessary. There's a little peak in the middle of that comb, and also you can see all these CVs being slightly off, especially the ones on the right side. And this is your opportunity to pull everything a little bit down or up, depending on what you need and what side you're working on. If you take time, if you take the effort, there's nothing that you can't do. Sometimes impossible tasks, seemingly impossible, can be just very simply accomplished, and at the end of the project, I mean, talking about myself, at the end of the project, I asked myself, who did that? Was it me, really? You know, sometimes I can't believe I can achieve these, these kind of results. But, you know, just carry on doing what I do here and you should be fine. Alright, so there's one more CV needing sliding, and after that, I think we are fine. We can always go back and tweak a little bit more if needed. Just remember that we are getting closer and closer to the final result, final successful result. Squeezing view is always a good idea, so don't be shy and squeeze anytime you need. Now, aligning, still the problem doesn't change. So what I'm gonna do now, I'm gonna quickly make this speed times 3. So we're going to speed up a little bit just to show you what ideas I'm having. So basically I'm trying to manually tweak the CVs and I'm keeping my fingers crossed. At the end of this sped up video, you will be able to see that I failed. But anyway, just watch me having different kind of workflow ideas. Just basically sliding, right? Sometimes, you just get lucky. But obviously you still need to pretend you know what you're doing, especially in the office environment. Still nothing, still can't get the tangent, which is again very, very weird because the comb curvature looks okay. Now what I'm gonna do, I'm just going to do one more thing. Basically, I planarize holes. That makes my curvature plot just a little bit better. I can also change the transparency of my holes and CVs. Now, so this is very, very important. I'm taking the edge of the round and I'm doing the extend with the merge off. So what I'm doing is I'm creating an extra patch. Now I'm going to take this patch and I'm going to align to the existing curves which I just created. The curves are from the previous patch. So this way I'm gonna keep this G2 continuity at bay basically. I'm trying to align to the middle curve, but it didn't work, so I stopped. Now I'm aligning the outer edge to the outer curve. I'm also trying to influence other CVs, just making sure that the comb is right and I'm not taking with me too many of the holes because I will lose the G2. I'm gonna delete the history. I'm going to save everything just to, to not lose anything. Now I am manually manipulating the rows of CVs and just make everything, as usual, everything nice. Remembering to not touch the first three CV holes. So basically G0, G1 and G2, I am not touching them. I'm very happy with the results. So this is the trick, okay? This is the trick that you can use. So once you're happy with the round, you can just basically manually create adjacent surfaces. We are getting closer and closer to the final result. Now basically it's the matter of sculpting it a little bit better, so you know the trick. By manipulating the CVs, I lost the continuity, as you can see. Aligning will sort out the problem. But again, I'm trying to keep in mind that the most important is not continuity, is the shape. So I'm trying just to slide everything and make sure it's close to what we want to be. So the form or volume is important as well. You always have to remember that. Don't just get involved, get bogged down with the continuities. That's not the most important. Surface quality is important, but obviously if the shape is ugly, if the shape is wrong, you kind of, you're wasting time. Okay, so continuity failure again. So what we're gonna do in this case, I think we can try to manually tweak, but I'm kind of tired of this. What I'm gonna do, I'm going to do exactly the same what I did first time. Basically, I'm going to extend with the merge off. So you see, I'm asking why still yellow? Why still these? I don't get the right continuity. So as I said, I'm going to do the extension again with the merge off. But I think I'm going to also slightly change the our round first, because the round still can be slightly tweaked. Minor changes here and there are very important, and don't be afraid to go ahead and do these changes if it's necessary. So again, I have G2 in here. Okay, so I have two patches, and what I'm gonna do, I have one patch which is G2, which is okay. This is the patch that I just extended with the merge off, and I have my original patch which I'm working on. So what I'm gonna do, I'm going to take the patch that I'm interested in, my own patch, take the G1 and G2 CVs and snap them onto the patch that I have just extended with the merge off. If you do it like that, you are 100% sure that the CVs are in the right place, and you don't have to use any align tool, which some of the time do not work. Okay, so yeah, there you go. Without even checking the continuity, I can see that I will have G2 in there. Again, I can see there's a peak in the comb. Tweaking, sliding helps, but again, it destroys my G2 continuity. Okay, so we are fine, and yeah, the comb is right. The continuity is not there yet, but it's very, very close. Let me just slide and see if I can manually get my continuity. To be honest, I'm not believing in miracles, and I'm not hoping too much, but here you go, I got it. Okay, so I'm kind of lucky in this instance. There you go. So this is the result we have. Of course, we are not that close to these to the data, as you can see. Just a slight movement of mouse. This is the kind of satisfactory result, and we could just like that move it, and I'm fine. I think I've made it. The nice 3 G2 continuity with the very consistent comb plot, and this is going to be the base of our nose of the McLaren 765 LT, and no one will come over to you and say this is wrong or something doesn't work, because the 3 patches we just generated are of very high quality. So I hope now you can understand what working backwards means. Basically, you create the most important, most maybe even difficult patch. In this case, it was our round, and you work around. Basically, you build your adjacent surfaces.